Hey everyone, welcome back to Tech with Machines. Today we are diving deep into one of my Python's most versatile and underappreciated data structures, sets. You might be familiar with lists and dictionaries, but sets bring a whole new level of power and efficiency to your Python code. They are like Swiss Army knife of collections, and in this video, we are going to unlock their full potential. Now let's continue with the outline while maintaining an engaging and informative style. So what today we are going to cover? We are going to go through the introduction, basic operations which set has, like how do you create a set or how do you add or remove elements from a set. What are the different set operations you can do? What are the methods which are applicable for set? And what does frozen set mean? And finally, if you like this video, please remember to like and subscribe. Alright, let's kick things off with the basics. So what exactly are sets in Python? Well, imagine you have a collection of unique items and you want to perform operations like checking for duplicates or finding common elements. That's where sets come in. So as you can see, set is generally a data structure which allows you to store only unique elements, which means there will be no duplicates, but it also doesn't preserve an order, which means elements order will not be maintained. It's generally useful for intersection, union, and difference. Now let's start that how we can create sets, and let's try to do some hands-on. As usual, I have created a new file called sets.py in my previous project's Python Kickstarter. You can also follow the same, or feel free to go back to my first video and check out how you can create a Python project and a basic setup of Python. Now, to start with, we will first understand how we can create sets. In our earlier videos as well, we actually went through the basic definition of set and how you can create it. So generally in Python, sets are created using curly braces or using a set function. So let's try to do it both ways. So what we are going to do is name our variable my set and give it the values, comma separated values enclosed in curly braces. So this is going to be 4, let's say 4, 5 and 6. So that's one way of creating a set. If you remember, tuples are also created in a similar way, but they use parentheses and lists use square brackets. So here you have a difference how you can create multiple sequence types, different sequence types in Python in different ways. Now let's figure out a different other way. Let's discover the other way, the set function, how you can create set. That's basically my set again, and use a set function and generally give it the list as a comma separated list. So we're going to do 1 2 3 4 5 and 6. So basically we created now set using two ways, one using just a simple way, curly braces, or other using the set function. Let's now try to print both way. So let's try to print the last one which we just created. So let's run this. So Python and the name of the file, which is PythonSets.py, and it is able to print our first set which we just defined. Now, how do you add elements to a set, right? So basic operations which you do on a set is adding elements to set. So how do you add elements to a set? So there's a method called add which set provides, and that you can use to add an element to a set. So basically what I can do is I can say my set dot add, and I can add 7 to it. Now let's try to print my set, and let's just comment out this set. I think I observed that I keep on printing multiple outputs and sometimes it becomes confusing. So I'm gonna for this video I'm gonna keep on commenting out the previous prints. So now here I'll clear the screen and let's run it. And as you can see, 7 has been added to this set, which was earlier just with 1 to 6, right? So that's how you add elements to a set. Now how do you remove elements from a set? Now, there are two ways to remove elements from a set. One is remove and another is discard. We'll also discuss what is the difference between two, but let's first see what they do actually. So let's try to remove with the remove method. So we are going to just remove, let's say, 3 from this list. And let's just comment this print out and we are going to deal with this one. So we'll say print my set and try to run this again, and as you can see 3 is gone, right? Also let's try to now use discard, okay? And we will just use again we are gonna just remove from our list set 7 for this time. And again we are gonna print my set, and let's comment this print again here, and we are gonna just print this, and this says okay 7 is gone. But now what is the main difference between remove and discard? We'll just see in a second. So let's try to now again use this remove, and this time we are gonna remove an element which doesn't even exist. Basically let's try to remove 3 again from the set, which now doesn't exist because we already removed it. So what happens? Let's see. If I just run it again, let me clear the console, and if I just run it again, you see that oh, it throwed an error saying that there is no key present like 3 in that. Now if I do the same thing with discard, and I just gotta change this to discard and run it, as you can see discard didn't really throw any error. It silently ignored it, and we don't have any key error, any runtime exception here, right? So so with discard you will never get any key error, whereas with remove you will get a key error, right? So if I just print my set after this, it is gonna be in the same state which it was earlier. That means it is not gonna have 3 and 7, and now when I print it, it is 1 2 4 5 6. So that's the main difference between remove and discard, right? Now this is how the basic operations are done in set. Now let's try to do some more advanced operations on set, like union intersection, for which it is very useful. So you are gonna do a union of 2 sets, or you want to do an intersection of 2 sets, or the difference, or the symmetric difference. Now what is the difference between each one of them? We'll go through. Now when you want to combine elements from 2 sets, right, and when you're doing union, remember sets property. Set only maintains unique elements. So if there are 2 sets and they have duplicates, they ideally will have duplicates. When you will try to combine them, it will just maintain unique elements. So let's try to do that. So I have a set 1, okay? Let's define set 1 and let's keep it simple. It's 1, 2 and 3, and let's define set 2, and which let's say starts from 3, 4 and 5. Now as you can see, 3 is duplicate here because it is present in both sets. Now if I do union on both, right, so let's try to save it in union set, and we'll try to print it as well. So let's name it union set equal to set1 dot union set2. Now let's try to print this. So what happens here now, if as you can see when we print it, it is giving 1 2 3 4 5. It's not giving that other 3 in set 2, correct? So it has just removed that 3 and kept only 1 3. So it continues to maintain its unique property even after doing the union operation, right? Now there are 2 ways to do union. One is set1 dot union set2, but then there is an operator pipe as well, which also does the same thing. It's just a short form of doing a union. So let's say again union set, set1, pipe set2. Now this also is going to print the same thing which we just discovered with the earlier print statement. Let's comment this out. Let's clear the screen, and once you print it, it is giving the same thing, 1 2 3 4 5. So this is all about union. Now we'll go through intersection. Now when you are doing intersection means that it is going to return only common elements between the two sets. So if we would have taken let's take the previous two sets itself, and let's try to do the intersection on them. So when we create an intersection set, again it has two ways. Either you do intersection method or you use the AND operator, right? So I do set2 and I try to print it. It should just return basically the common element. Now once we run this, you can see that it is just returning 3 basically, which is the common element in both, whereas in earlier one it basically dropped one of the 3's, right? Now other handy way of doing intersection is, let's try to do that as well. So you do intersection set, you do set1 and you do set2, and then just print the intersection set. So it's gonna print the same 3, right? So that's how intersection happens. Now what is difference? Difference is when you do whatever set you are basically doing difference on. So whatever first set will be there. So whatever elements are there in the first set, present in the first set but not in the second set. So that's what difference means, right? So let's try to do that with the same thing. So we'll say difference set. So let's do this, and we'll do set1 dot difference set2, and short form is of course minus here. So we are just gonna use for time constraint, we'll just use a difference for now, because I think you are now you have now gotten the idea, the other handy operators which are available for these methods as well, and you can use them, right? So here we'll just print this, and once we print it, you can see that it is okay. Let's try to just comment this intersection print, which was the earlier operation, and let's try to just print the difference set. And as you can see, it is just printing 1 and 2, which is only in the set 1, and they are not present in set 2. 3 being overlapping with set 2 is also being dropped, and 4 or 5 were anyways in set 2, and 1 and 2 are the only ones that are not present in set 2, right? Now I would have changed the order and should have done set 2 minus set 1, then let's do the other operator, use the operator here itself. So now if we do difference set, we're going to print both. So the first one says 1 2, but the other one says 4 5, because now it dropped 3 1 and 2, correct? So that's how the difference set works. Difference works, basically difference method works, that the elements which are present in the first set but not in the second set. Now what does symmetric difference mean? So what is the difference between symmetric difference and the difference? Now in symmetric difference, it means the return elements present in either set but not in both. So they will be in either set, but they should not be in both sets. So which means in this case 3 will be dropped from both, right? So we will, if we do symmetric, let's call it symmetric, and we do set1 dot symmetric difference set2, and just print this symmetric. Let's comment the other previous methods and just run the output of symmetric. So if we do this and run it, you will find that it actually dropped 3 from both the sets. So that is what symmetric difference means, that return the elements which are present in either of the sets but not in both, right? Now there are other methods as well which you can apply on set, like clear. Now what does clear do? Clear actually will remove all elements from the set. So if I do let's say I do set1 dot clear and basically do print set1, let's try to do this, and I'll just comment this symmetric out, right? And let's try to set this. So as you can see, it has cleared the set 1, right? Let's try to see before clear as well, so that it's much cleaner and understandable. So let's try to do this. I'll print set1 first, which has elements which is 1 2 and 3. So ideally it should print 1 2 and 3, and then when we do clear, after that It should not show anything, it should show an empty set. And that's what it did. Once we call the clear, it's actually showed us the empty set, right? Now, let's do copy. What does copy mean basically? Let's comment this print statements here. And what does copy do? Copy actually returns a shallow copy of the set. Okay, so set1 dot copy. Let's say I am doing set1 dot copy set2, and then I just, sorry, not clear, actually copy, and then basically it creates a shallow copy of not what I did, sorry. So I'll do set1 copy set2 basically. So what will happen here is, wait 1 minute. So set2 dot copy, so it will actually copy set2 now in set1. So if I do print set1, which I actually cleared, would have 3 4 5 now. So that's what copy means. Copy creates a shallow copy of a particular set on which you are applying this method. Now length in general is just length, which we used to do with the list and tuples as well. So length of, let's say, set2, it is going to give us 3 in general. So that's what it gave, right? That length of this particular set is 3. Now what is in operator? In operator is only if checks for if the element is present in the set or not, right? Or in a particular sequence type or not. It's applicable even for tuples or dictionaries or list, right, in Python. So let's say I am going to ask it that if you have 3 in set2, so what does it do? Let's try to print this in general, and if I do that, it says yes, I have 3 in set2. Let's try to also use it in different way, and I will say something which is not there in set2, like 6. So if I do run this for the first and the second one, it says for the first true, yes, I have it, and for the second one it says false, correct? So these are the very basic operations of sets which you will basically encounter when you work with sets. Then there is another type of sets called frozen set. Python also supports frozen sets. Now this is a immutable version of the set, which means if once created, you can't really modify or add or remove elements to it. So this is useful when you need like a hashable set, right? You want to use set as a key in a dictionary, then frozen sets make more sense. So you want to use it as a key in a dictionary, and it should be immutable, so you can use frozen sets in that case, right? So how do you create a frozen set? So let's call it my frozen set. Let's say my frozen, and then you can actually call frozen set function, and you can pass the list of elements which you want to. The same way as we did set, we did it with set function. Now frozen set is with frozen set, right? So now if I print my frozen, let's comment the other two in statements here, and let's try to run this. As you can see, it is giving me the frozen set, right? So in general, sets are versatile and they are efficient for various tasks like removing duplicates from a list or performing set operations. So they are an essential tool in Python for dealing with collections of unique items, right? So this is where it leads us with sets, and I hope you are now armed with the knowledge to harness the true power of PythonSets. And remember, learning Python is not just about learning a syntax, it's also about understanding how to leverage its features to write cleaner and more efficient code. That's it for today, folks. If you found this video helpful, don't forget to smash that like button and share it with your friends. Feel free to subscribe, and if not, come back and learn along with me. Until next time, happy coding and happy learning.